Here we're applying reduction of order to figure out the second solution to this differential equation. Let's go ahead and get started. So y2, we're going to guess, is some unknown function v of x times y1. So it's v times e to the x. Alright, so then I'm going to need y2 prime. Alright, that's going to be v prime e to the x plus, it's just v e to the x. There's nothing that gets dropped down because it's just e to the x, not e to the 4x or anything. Let's go ahead and simplify that so it's a little nicer. So v prime plus v e to the x. Alright, then we have y2 double prime equals, alright, take the derivative again, we get v double prime plus v prime from the first half of the product rule. In the second half, we pretty much copy it because the derivative of e to the x is e to the x. So v prime plus v e to the x. And alright, we can simplify that into v double prime plus 2 v prime plus v all times e to the x. Alright, now we plug it into the original ODE. Alright, so we have x minus 1 times y2 double prime. That's going to be our v double prime plus 2v prime plus v times e to the x minus x times y2 prime, which was v prime plus v times e to the x. Then we have plus y2, which is just v e to the x. And that all has to equal 0 for this to work out. Alright, so now let's try and group it by different derivatives of v. So we're going to have an x minus 1 times v double prime. Now I'm going to put the e to the x on the end of everything. Alright, then I got plus. Now all the v prime terms, I have 2 times x minus 1, so that's 2x minus 2. Then I also have a minus x v prime. And I think that's all the v prime terms. Then plus, these should cancel out as usual, so I have an x minus 1 times v, so x minus 1. I have a negative x times v, so minus x. Then I have a plus 1 times v, so plus 1 v, all times e to the x, should equal 0. Alright, then simplifying this, we end up with x minus 1 v double prime. Let's see, 2x minus x, so x minus 2 it looks like, times v prime, and then x minus x and negative 1 plus 1, we end up with 0 v's, so it looks like there's a good chance I did the algebra correctly. So e to the x equals 0. Alright, so e to the x, we can essentially divide both sides by e to the x. It's never 0 no matter what x is. So the new differential equation to solve is x minus 1 v double prime plus x minus 2 v prime equals 0. And to get that to look like a first order differential equation, so it's not so confusing, we'll pick w of x equals v prime of x, and that means w prime of x equals v double prime of x. So then our equation becomes x minus 1 times w prime plus x minus 2 times w equals 0. Alright, so let's go ahead and try and simplify this. Looks like it's going to be nicer maybe to separate this. So let's go ahead and move some things over. So we've got x minus 1, I'm going to write that as dw dx, equals, so I move this over to the other side, so I'll end up negating that, so it's 2 minus x times w, and then separating we'll end up with, let's see, 1 over w dw equals 2 minus x over x minus 1 dx. I want to get that to look a little nicer, so that's the same thing as, let's see here, I want 1 over x minus 1 plus 1 minus x over x minus 1. Right, so the 2 I split up into two different ones. And that's all dx. Then that simplifies into 1 over x minus 1 minus 1 dx. Right, then we can go ahead and integrate both sides. So integral 1 over w dw equals the integral of 1 over 1 x minus 1 minus 1. Right, so that ends up being natural log absolute value w equals, alright, so this one will be natural log absolute value x minus 1, and the minus 1 turns into minus x, and then if we're being careful, we're going to add that plus c. Alright, next up we want to get w by itself, so then we're going to exponentiate both sides. So e to the natural log w, right, that's going to be absolute value w equals e to the natural log absolute value x minus 1 minus x plus c. We can write that as e natural log absolute value x minus 1, that's just e to the negative x, and then e to the c. And that will become absolute value x minus 1, right? The absolute value and the natural log cancel. Sorry, the exponential and the natural log cancel. We still have our e to the negative x. E to the c is just another constant, so I'm going to call it c. And then we still have our absolute value here. We're going to go ahead and drop that because the c can take care of it. So we end up with w equals, I'll rearrange a little bit, so c e to the negative x, x minus 1. But we're not done. So w, right, we don't care what w is, we actually care what v is, and w was v prime. So we actually have another integral to do that's a little worse. So v prime equals c times e to the negative x times x minus 1. I've run out enough room to do this. We're going to have to do an integration by parts, and then go back and finally solve for y2.